Today our lecture is rectangular component of vector. In this video we will learn that how to find the rectangular component of any vector quantity except these two types. First is fixed vector, second is free vector. Fixed vector are those vectors whose initial point or tail is fixed in space. The example of fixed vector is displacement. We cannot find the rectangular component of displacement. Second is free vector. Free vector are those vectors which is only defined by magnitude and direction, and this vector is represented by direct line segment, and the example of free vector is momentum. Whenever we use the word rectangular, it means that we have Cartesian coordinate system in 2D or 3D. We find the component in two dimensions along x-axis and y-axis. This is origin. As in the unit case of unit vector, we see that any vector can be represented in terms of unit vector like ux, a unit vector, uy, j unit vector. If the vector is in two-dimensional plane like x and y, and let we have an vector force which is applying on a certain object. Force is a vector quantity. You can use here acceleration or velocity, which is making an angle theta along the x-axis. And the vector force can also be written in terms of unit vector like vector force is equal to fx I unit vector plus fy j unit vector. It means that force fx is the component along the x-axis and fy is the component along the y-axis, because fx is the coefficient of I unit vector which is on the x-axis and fy is the coefficient of j which is along the y-axis. If we draw a perpendicular on the x-axis, then this perpendicular is parallel to y-axis. We name it as fy, and the distance that is covered under the vector f along the x-axis, like from O to that intersection point, this is known as the x component of the force. If you look at the diagram, we are seeing that it is a right angle triangle. Let me explain that. This is a right angle triangle. This is its fx, fy, f, and this is angle theta. The opposite side of theta is known as opposite because this is the basic trigonometry. The side along the theta is known as adjacent, and the side opposite to the right angle known as the hypotenuse. We want to find the values of fy and fx. So let's see. Fx and f has a ratio, mean adjacent and hypotenuse. Adjacent divided by hypotenuse, which is equal to fx over f. And from the basic trigonometry, we know that adjacent over hypotenuse is known equals to cos theta. We want to find the value of fx, so multiply by f both sides, we get fx is equal to vector f cos theta. We use the magnitude of the vector force to find the value of the rectangular component on x-axis. This is the x component of the force. X component of the force. Now we use to find the y component this ratio opposite divided by hypotenuse, which is equal to Fy divided by F, and we already know from the basic trigonometry that opposite divided by hypotenuse is known as sine theta. Again, multiplying by both sides with F, we get the F sine theta. So this is our Fy component of the force. Now we want to find the value of the direction theta. How can we find the direction of vector force? So if we name this vector A1 and this vector, this component name 2. So by dividing 2 with 1, we have Fy divided by Fx, which is equal to F sine theta, the value of second value, and divided by the value of first component F cos theta. F cancel out with F. Sine theta over cos theta, we know that this ratio is equal to tangent theta. So the value of theta is equal to this tangent. We multiply both sides by tangent inverse, then it is also equal tangent inverse. So tangent inverse Fy over Fx. This is the relation to find the direction of a vector in coordinate system. It is very important topic. It has very important value in physics, engineering, and other branches of the physics, engineering and mathematics like mechanics. So in the next video we will see the very important topic, product of the vector. Thank you for watching the video.